Meet Fuser, Linux's overlooked detective. When a file refuses to be deleted, a disk refuses to unmount, or you just need to know who's holding a resource hostage, Fuser answers one precise question. Which process IDs are using this thing? Point it at a file, directory, or socket, and it hands you the PIDs. Now let's open the tool belt. Run Fuser with the V flag for verbose output, and you get a full suspect lineup. User, PID, access type, and command. The access codes tell you exactly how each process is touching the file. F means the file is open, C means it's the process's current directory, E means it's running the file as an executable, and M means the file is memory mapped. When you pair V with the K flag, Fuser escalates from detective to enforcer. It doesn't just identify the processes blocking your target, it kills them. This is the move when a stuck mount or wedged file needs to be freed, and you've already identified the culprit. Fuser doesn't stop at files. The N flag lets you change namespaces, pass TCP and a port number to ask who is listening on that TCP port, or UDP for the same trick on UDP sockets. Need to know what's serving traffic on port 80? Fuser NTCP 80 hands you the PID of the web server in an instant. Two classic use cases define Fuser's value. First, why can't I unmount this disk? Because a process still has files open on it. Fuser names the offender. Second, who's listening on port 80? One quick Fuser command returns the web server PID. Both scenarios share the same pattern. A resource is locked, and you need the culprit fast. So how does Fuser compare to lsof? They overlap, but the philosophy is different. lsof is the sprawling investigator. Give it a PID and it dumps every open file, socket, and pipe that process touches. Fuser is the laser-focused interrogator. Give it a file or port, and it returns only the processes using that exact target. For deep forensics, lsof wins. For one quick, precise question, Fuser is faster and cleaner. Fuser isn't flashy, but it's indispensable the moment a file system fight breaks out. Learn the V, K, and N flags, keep it in your toolbox, and you'll never stare at a device's busy error in confusion again. Fuser identifies which processes are currently using a file, directory, or network socket. Running it with no arguments prints a complete usage reference, including the flags we'll use. V for verbose output, N to select a namespace, and K to kill offending processes. The trailing status codes tell you whether a search actually found something or merely failed. The K flag tells Fuser to send a signal, by default SIGTEL, to every process using the target. The V flag enables verbose mode, which adds extra columns like process owner and command name. The N flag selects the namespace, TCP or UDP for network sockets, file for files, and PID for a specific process ID. We'll combine these flags against /TMP and TCP port 22. Before we run Fuser, a quick clear keeps the screen tidy. Then we run Fuser verbosely against /TMP, piping through head so the output stays compact. The first column is the PID, then the access flag. F means the process has the directory open, and F indicates a waiting open in the same directory tree. The user and command columns appear because of V. You'll typically see shell sessions, package managers, and daemons that keep files open under /TMP. Now we point Fuser at TCP port 22, the SSH daemon. Without V, the output is intentionally minimal, just the PID followed by the access letters. If nothing is listening, Fuser exits with status code 1 and prints no PIDs. Here we see a single PID owning the socket, confirming the SSH service is bound and reachable on port 22. Adding V to the TCP query is where Fuser really shines. The verbose table now shows the PID, the access mode, the owning user, and the full command line. The F flag means the process has the socket open for future access, exactly what an SSH daemon does while listening for incoming connections. This is the form you'll use most often when troubleshooting, port already in use, or who is holding this socket. You don't always need Fuser to identify a binary, which does that job and nothing else. Running which Fuser returns the absolute path, here /usr/bin/Fuser, telling you where the executable lives on disk. Unlike Fuser, which scans live kernel state for users of a target, which just consults your path to locate the binary itself. The two answers a fundamentally different question. Who is using this? Versus, where does this live? The other heavyweight in this space is lsof, list open files. lsof is a general-purpose inspection tool. It dumps every file descriptor, socket, library, or directory any process has open. Fuser is the inverse. You name the target and it tells you who has it. Use lsof when you want a wide snapshot of system activity. Use Fuser when you already know the target, a stubborn mount, a busy port, or a shared /TMP file. And you just want the offender's PID.